Hi everyone, today I would like to start with a new series where I want to discuss about the fundamentals of how SQL works and the SQL tuning, which has helped me over the many years where I have written a complex queries or tuned the database queries where the tables involved millions of rows and even more than 100 million rows. And for simplicity of our discussions, I would try to keep it actually very simple as opposed to actually talking about too much of a theory in my session. So as part of this series, I'll be creating a multiple smaller videos so that it becomes more easy to understand. As part of this series, I will start with how SQL works, in which I'm going to talk about that what happens when you write an SQL and what behind the scene happens. Then how does indexes help and what they really do behind the scene. Then I will talk about that if a table have a more than one index, then what choices database or how does database decides which index to be used and what kind of conflict might occur. Then I will talk about if the tables are significantly used, then how does actually partitioning really work and what are the challenges you face with when you do a partitioning incorrectly as well. Then at the end, I'm going to talk about the columnar data storage. So historically, database keeps data into the row format, it stores in a row format, but just for a specific retrieval purpose, database now started having a columnar data storage as well. So how does that work is also I'm going to cover. So let's jump to the first topic, which is how SQL works. So the first thing let's get started with is SQL is a fourth generation language. As opposed to that, all other languages which we typically work with, let's say C, C++, Java, all these are more of a third generation language. Now the question might come, what does it mean and how it is relevant for our SQL tuning? So to understand that, let's jump to the code. So as you can see on the left hand side, I have a simple query, which is that select star from employees where name is equal to Rajesh. On the right hand side, we have a code which is written in this particular case Java language, but it could be anything. So let's say that you would be having a list of employee data set, and then there is a function called find employee, which is taking input parameter as name, and then you would be having a loop which is iterating through the employees objects, and then within that iteration we are going to actually check for a condition. But let's say actually before that, let's add another data set in which we are going to collect the return data set. Okay, so let's create a list and a new array list, and then in the if block we just check for that when we are iterating through the employee object, what is the name of the employee and does it match with the input parameter which has been passed, and if it is yes, then we should be adding this record into the return data set. And once we are done with the for loop, we should be returning the final record data set. So as you can see, in fourth generation language, all we did is we specified the requirement to the computer that we want to select the data from employees for a given name, versus in third generation language, we give the script to the computer. We tell that, okay, you are supposed to iterate through the employees data, you are supposed to check the name is matching or not, and if the name is matching, then it adds into the return data set and then return the data set. So we're giving a specific instructions to the computer, versus in fourth generation language we are just giving the requirement to the computer. Now important thing to note here is that even though on SQL side we are just giving the requirement, however the system is still doing exact work which is there on the right hand side. It's just that SQL engine, the database engine, converts these instructions which are given on the SQL to the final scripts which computer must be running. So even though we are not writing it, the database is still doing exact work. It is iterating through the employees record, it is doing the comparison, it is getting the data set, and then even returning finally back to you. Why it is important is because if I ask you on the right hand side that if there, let's say that employees are millions of employees we have, and can you actually find out based on name, and you probably will think about it that is this the right thing to do, actually iterate over the employees again and again, as opposed to if we ask you to do the same thing on the selected statement, you may not be actually thinking much before you are actually writing this kind of query. But at the end, understand that system is doing exact same thing, that it is iterating those records and then giving the data set finally outside. So let's see that we have a situation where we have employees with the millions of data and we want to actually search it faster. So what would we do it on the third generation language side? We would probably create a map where we would actually keep a key as a name and then value as a list of employees which are matching the name. And then instead of the entire for loop, what we would do is we will just return by the getting by the key. Now, this is exactly what the index looks like on the database side. We just define the index, and behind the scene, database maintains a separate storage for indexes where it stores the data by the key of the index column which you have specified and the value as the records which are matching with the index. And that helps in terms of the faster retrieval. But at the same time, you can imagine that there is some extra cost involved here. One is that there is extra storage is required, and then second is that any point in time, if any change is happening in the employee data set, database need to update the record as well as the index. So as you can see in this particular Excel, that let's say that there is an employee data set which has a key as ID as 1, 2, and 3, and then name as Rajesh, Jim, and Rajesh. And if you have an index, then there would be a separate index, and where the key would be the name of the column or value of that column in the index, and then the value would be more of an ID. In true sense, database stores slightly differently, but for understanding purpose, I think this should be good enough. So you can see that first one is a Rajesh is the key and the value is a 1 and 3, and the second key is Jim and the value is 2. Now let's say that somebody fires an update query on this record set. So I would be actually writing a query like update employees and then set the name as James for employee ID is number 3. Now in this particular case, in the storage side, what need to happen is that the record need to be updated, its name need to be updated to James, and at the same time database need to also update the index where the first key, the 3 should be removed from the first set, and there is a new key should be added, James, and then the ID should be added there. Now this is the additional operation which database need to perform. So considering that you are writing the SQL query and you're just writing the update statement, the beauty of the fourth generation language is that you don't need to worry about to maintain the indexes and all those things. That is something which database has taken care of. At the same time, it is important for you to know that what is happening behind the scene, because as you can see that like if you create a table and you created too many indexes around it and your general operations are data intensive operations, insert and update are too frequent, then you can think about it that there would be additional slowness you might observe it. And that's where it is important to realize that even though in fourth generation language you are writing a small thing, there is a good amount of work which gets done by the system. At the same time, I do want to add that mostly you have more frequent read operations as opposed to actually insert and update operations. So this is important to know that adding indexes may have some additional cost, but mostly what I've seen is that retrieval is where you actually run into issues, not at the time of the insert update. So just be aware of it that there is a cost involved into it, but at the same time it's not that you do not add the index where it is required. All right, so let's come back to our agenda. So for the today's session, I have covered how SQL works and how indexes work, and did a comparison in terms of that how it would have looked like actually if we were writing the program or we were giving the scripts to the computer, which database is doing behind the scene. Thank you very much.